Hi, so today we are going to be talking about web scraping and graphing, and this is for a 351 Screencast project. So what we're going to be going over today is we're going to be taking this Cubs baseball reference website. We're going to be scraping stuff off of it. We are going to be graphing stuff with the data we've scraped off. We are then going to be making a function to pull this information off of online and create data sets by ourselves to find the best hitter for the data sets. And then we are going to use a different data set to create a interactive graphic for finding baseball team stadium locations and the map around it. So to first get started, this is kind of what the baseball reference page looks like. So we have, oh, and I'm kind of frozen here. Let's see if I can get this figured out. Okay, let's see here. Okay, so now that you've seen that page, hopefully you can see my our studio page. And so we're going to be scraping data off that baseball reference page. And we'll be going back and forth to kind of coordinate and see what data we are actually getting and where's it all from. So our first step is going to be to read the data. So we're going to say HTML, and these are all the functions that I have. Um, these are all the packages that I have lined up for us that we're going to need. So I'm going to go ahead and run these guys. Move my little picture out of the way here. Run those lines. Okay. Now I'm going to go ahead and use this function called read HTML. And I'm going to go ahead and go back to my screen sharing or my web page. I'm going to copy the URL in the search bar, and I'm going to come back to my search bar page and I'm going to type this in. Boom. And that's pretty much all you have to do to read in a basic HTML page. And now we pull up this and we see we have a couple different levels here. And what we're interested in is the HTML tables that are given in our documents. So we're going to call a little variable tables here. We're going to say HTML. We're going to use a little pipe function. And we're going to go HTML tables, which is a great function in HTTR that allows us to extract the tables that are already in great form that we can use as and put them in a data frame form in R, which is great. So let's go ahead and read this tables function in. Okay, can't find function HTML tables. Well, probably because it's called HTML table. That's why. Okay, let's go ahead and run this again here. Um, okay, great. Now we have a list of one tables. Okay, so we have all these things here. Let's go ahead and put this table into a data frame so we can kind of view this a little bit better. We're going to go ahead and call this Cubs data.frame. Let's see here, tables one. And this is going to extract this table and put it in a form that we can actually use it. And that's not in such a foreign form, excuse me, especially for people who have never web scraped before. So we're going to go ahead and run this Cubs function here. Let's go ahead and run this guy. All right. Okay, there we go. Now we see we have year, we have team, we have league, game, we have win-loss, we have a bunch of stats about each season that the Cubs have played, which is awesome. And we're going to try to graph some information about these guys. We're going to try to graph wins and losses. We're going to try to categorize them by league. We're going to try to do a couple different things there here. First off, what we're going to do is I want to categorize these guys by the best and the worst years. So I want to pull out those worst and best years. So we're going to call this worst year. I am going to go ahead and pipe my Cubs data set. And we are going to filter using a filter statement. We got a lot of filter statements in the beginning here. There's this variable called win-loss, and I'll pull that up here so we can kind of see what win-loss looks like. And here it is, win-loss. And it gives us the winning percentage for the season. And what I want to do is I want to filter this percentage, And I want to say I want this percentage to be less than or equal to 450 for this worst year thing, for this worst year data frame, right? And then I also want to create a data frame for best year. So I'm going to call it my best year, and I'm going to run it in, pipe it off the Cubs data set again. I'm then going to filter. I want to filter off my win-loss. So I'm going to get in here and do win-loss. I'm going to do greater than or equal to, though, and I think I'm going to choose 650 as my cutoff for the win-loss percentage because winning winning 65% of your games in a baseball season is amazing. And that's an amazing season. Now winning 45% of your games is not. So we're going to go ahead and use these two as our categories here. Okay, we now have our two categories. Let's go ahead and look at worst year. Hmm. We might have chosen. Nope. This is Cubs are just not very good. This is exactly, yeah. So there's a lot of seasons on here. And my guess, if I go to best year, yep, there's not too many seasons. And in fact, there's not a season from this century, which is not great. So let's go ahead and look a little deeper into this information here. Let's go ahead and try to combine this into a singular data frame. We're gonna go ahead and get in here and make a variable called type within these data frames so that we're able to signify what when we combine these two data frames, worst year and best year, we're able to signify which group they're part of. And we're going to create that so we can actually graph these and display them a little bit easier. Now I'm going to call this winning percentage greater than or equal to 0.650. I'm then going to go into worst year. I'm going to do the exact same thing. Then I'm going to do less than or equal to 450. Okay, now we're going to do this. Oops, didn't highlight that all the way. Let's go and run these guys. Let's look in worst year and let's see what we have. We do have our type, all these less than 450, winning percentage less than or equal to. Okay, now let's go into and make and combine this data set. Let's call this year. Let's call this years. We'll call it years. And then we will just row bind these columns here. Worst year, best year. Okay. And let's see what our years data frame looks like. Years. Okay. And here we have all the seasons that are both, and of course, all the good seasons are at the bottom, of course. We have all the good seasons and bad seasons that the Cubs have played, kind of in the history of the game. All right. Now let's continue with our analysis here, and we're going to go ahead and do another little filter statement. We're going to call this statement Cubs years, and we are going to go ahead and sort this by years. So we're going to call this Cubs. Oops, I'm going to caps lock on. Still have it on. Still have it on. Cubs. We are going to then filter the statements. Filter. So if we're not in year, so let's go back to our Cubs data frame. So we're going to say, oh, I got the screen share thing right in my face. Okay. If we're not in year, let's go ahead and find year. Okay, here we go. Here's year. And we're going to pull all the information from this data frame and move it into our best year. And I'm going to see if this actually makes any difference. We may not actually need to do this. Let's see. Let's see what this kind of does here. So what we did here is basically we created a data frame that is the opposite of the worst and best seasons. We created a middle range data frame. And why we do that? Because I'm going to say Cubs years, plus type. Now I'm now going to do w.p. In fact, I might even do this. It's greater than 450 and it's greater than less than 650, right? So we're going to create this little variable here within our years. So we can go ahead and graph these and get a good sense of the Cubs, where they stand in winning percentage over time for their whole history, which they've been one of the oldest baseball teams for a long time. So they have been around obviously for a while. So now what I'm going to do is I'm going to create this data frame called Cubs total, and I'm just going to combine the data frames that we have created. I'm going to combine, typing is an issue today. I'm going to combine them into a singular data frame. Cubs years, years. Great. Cubs total. We should have 300 or 150 entries in Cubs total, and we have 150 observations right here. So that's great. Okay. Now what we need to do is we're in now the position where we can start creating graphics. But there's one extra thing that we can do, and that is there is a library in R called MLB plot R. This library contains information on pretty much every MLB team, and I'm going to show you guys what that looks like here. I'm going to call this data frame colors because what we're going to do is we're going to actually pull out Cubs colors, the Cubs actual colors, royal blue and marquee red, I believe is what the Cubs colors are. And Cubby blue, of course, if you're a Cubs fan. And we're going to go ahead and put those into our graphs, which is pretty cool because we can do that with this. We can do load MLB data or MLB teams possibly. Yeah, let's see what this looks like. Let's see what this colors data frame looks like before we edit anything out. Load MLB teams. Well, that's because I probably have to do this. Okay, we go to colors here. Great. Okay. So here we can see team name, team location, mascot, abbreviation, ID. We got logos, and these logos are real. I can go ahead and do this. Copy. I can switch my screen sharing and show you guys what this logo looks like. Let's go here, share. There. And now we can see this is the Arizona Diamondbacks logo. That's from our data set. So these logos are real, and we're just going to use those later in our graphics that we go ahead and display. So now we have our MLB Teams logo, or we have our MLB Teams data set, apologies. And then what we're going to do now is we're going to go in and sort out all these colors. First off, to do that, to get our Cubs colors, we need to filter our team name by Chicago Cubs. And that should be what our team name is in this data set. Let's go ahead and just check really quick. Chicago Cubs, good. Let's check what we're looking at here. If we can get all this here. Good. We have just the Cubs, which is great. And now we just care about the color. So I'm going to go in, and how do you do that? You use the select function. And you go ahead and you choose team. Color name is team color and team color 2 because we need two colors because we want it to make the graph the way we want. We're going to want two colors. Okay. And then so the next step in our data analysis is going to be graphing techniques, right? So we're going to take this information and then we're going to go graph it. So we have pulled the color information. Let's run this data set so we actually have it fully here. And we have our color number per se. And this is what's going to go in our graphic. So let's go ahead and come down this way. And we have this Cubs total data set. And I've already typed some of this out to save us a little time here. Let's move some of this up here. And we have this Cubs total graphic that we're going to make here. And we're going to see how this kind of all comes together. So let's go ahead and run this. So what this is taking Cubs total, this Cubs total data frame. Here, let me pull the Cubs total data frame up. No, I don't have that one up. Cubs total. Okay, this is all the years with our type columns. Okay. What it's going to do is we're going to assign this team color 1 to people that are above 650. Team color 2 is people going to be below this, below 450, and then gray to people that are in between. And labs, we have obviously our titles of our graph and things of that nature. And we're going to be graphing in our x-axis, we're going to have year. In our y-axis, we are going to have our win-loss percentage, and the fill is going to be the type. Let's go ahead and run this here. Okay. And this is going to be obviously like a column graph. So we're comparing winning percentages across years, and as we can see, the Cubs have a lot more losing years than they do winning years. They do have years where they've won the World Series, which actually, ironically, they did not win over 65% of their games. So what we're now going to do is we're going to create a winning category. This Cubs winning category is basically going to break up the Cubs winning percentage into, what do we have here? 4 groups. 0 to 400. So basically, you're winning 0% of your games to 40% of your games. You're winning 40% to 50% is another group. And the next group is a 50 to a 60% chance, and 60 and above is our next chance. So let's go ahead and create this Cubs winning category. All right, great. So we go ahead and created that Cubs winning category. Delete this guy. So now what we're going to do is we're going to graph this. And how are we going to graph? We're going to use ggplot, right? So we're going to use ggplot. We're going to use your Cubs data frame that we've kind of been editing this whole time. We're going to use your year. We're going to use your win-loss percentage. And we're going to fill by the league. Okay. Why are we going to fill by the league? Well, because we want to see what the league differences are. So we want to see, because the Cubs have played in multiple divisions across time. Originally, they just played in NL. There was no divisions. And then they were playing in the NL East. And now they're playing in the NL Central. So we want to see how these different divisions have affected the Cubs winning percentage. And let's go ahead and see what that looks like here. Okay. Here we can see that the Cubs winning percentage in each division. We can see that obviously before 1900, the Cubs were all-stars. The Cubs were great. They won the World Series in 1908, 1907, and then they didn't win it again until 2016. So there's a lot of rough years in the middle there. So as we can see there, they came to NL Central late 1990s, or not late 1990s, late 1900s. And they have been in the NL Central ever since. And here we can just kind of see visually comparing the NL when they were just in the NL, NL Central, and NL East. That's a good little visual comparison there. Now we want to go ahead and go compare the Cubs playoff appearances um, in each year. So what we're going to do is we're going to create this Cubs playoff appearances variable, and that's going to be this variable right here. This Cubs playoff appearances variable is going to basically detect if there's a value. Let me find my Cubs data set here. If there's a value in this playoffs column, they made the playoffs, right? So we're going to detect if there's a value at all in this playoff column. And what I chose to do that with is string detect Cubs playoff O. Reason because a win, um, loss has an O, and I chose that for another reason as well because one has an O. So either they won or they lost, and so they're always going to have an O in this playoff category no matter what. So we're going to go ahead and run this thing here, run this little chunk. Okay. And basically it's going to be a 1 or a 0. So if they made the playoffs, it's going to be a 1. If they didn't, it's going to be a 0. And then we're going to make another graph here that's basically x-axis is going to be the year, y-axis is going to be the win-loss percentage, and we're going to fill by the playoff appearances. Okay, so let's go ahead and fill by the playoff appearances here, and let's see kind of what our graph looks like. Okay, this is not what you want to see as a Cubs fan, because I'm looking at this data set, I'm seeing a lot of red. and a lot of zeros, which means I'm not making the playoffs a lot, which isn't good. But as we can see a good representation of the Cubs winning team throughout history. In the beginning, playoffs weren't as much of a thing. So the Cubs weren't making the playoffs as much because the playoffs weren't necessarily a thing. And now when the playoffs started becoming a thing, the Cubs made a couple times. Obviously, they made a couple times in the 1900s. And the playoffs have kind of expanded over time. It used to be just the World Series, and then it became a series, a National League Championship Series, an American League Championship Series, and then expanded again to like a divisional series. Now there's like two tiers before the World Series, and now there's even three tiers with the wild card series, and that's what the Cubs made this year in this 2025 category. So that is the Cubs graphing data. The next thing that we're going to go do is we are going to look at how to create a function to pull information from offline and implement that function to find the best hitter for pretty much any baseball team that we can imagine. Okay, so the goals that we have for today is one of the goals we have is to create a function that is going to take into consideration the team, the year, whether we're talking about regular season or playoffs, and then what was the other one? Hitting or pitching. So, how we do that is we are going to be parsing URLs, scraping that from online, um, building a function that is already built. We're going to go through it, and then using that information, the data set that we pull off, to then describe or discover the best hitter for that team. Okay, so what we're going to do is you can see this URL here. This section of the URL is common for every single team that we are going to be dealing with. This is a team ID. Each individual team has a team ID, and that's going to be placed in there. Obviously, 2025 is going to be the year, and that is going to be, I'm sorry. That is going to be what we are sharing or what we put in the year, where we put the year in that we are wanting to look at. And then we're going to look more into the playoffs and the hitting sections once we go into the details of our function. But we have to, how are we supposed to know the team IDs, or how is the person using the function supposed to know the team IDs? And then how are we supposed to know what year these teams have available? Because a team like the Montreal Expos isn't a team anymore. Or teams like the Anaheim Angels changed their name from the Anaheim Angels to the Los Angeles Angels. Or a team like the Chicago Cubs, which has been around since the 1800s. So what we do is Baseball Reference actually gives us a key. And what we are going to do is we are going to build a key and then go through the function. And well, let me share my screen to the right page and build a function that will pull these data frames from online, pull the data tables from online, and then allow us to access the data tables. So what we're going to do is we're going to build a key called MLB codes. Let me sweep here. All this stuff here. MLB codes table. And what we're going to do is we're going to read HTML, right? Okay. Put these in quotes. All right. We're going to read that HTML. We're going to put this in a HTML table, the same function we used earlier. We're going to run this. We're going to run this guy. Okay, let me delete some of these guys off. Here. Okay. Here we have our MLB codes table. As we can see, it's yet again just the table like we had in the same format before. And we can put that into a MLB. Ooh, sorry. I'm just going to call this MLB code. MLB code, MLB codes table. We run this up. And here we have our MLB code. As we can see, we have some column issues, column name issues, which are in the first row, and this should be column names. So let's quickly change that up. And then it looks like we have a franchise ID and a team ID. We actually don't need that franchise ID. So we're going to get rid of that. But then the rest of this is going to give us a key, which is going to allow us to say, here's our team ID, here's the team name. So how you'd use the key is you'd search for the team name, you'd you look for then their ID, and then you'd be able to look and see what years they were available to search from. And now, granted, all of these teams that this key has don't have data in all of them at MLBreference.com, but a lot of the newer ones will. So a majority of the newer ones were. It's a great resource for all baseball information. We're going to call this columns. We're going to call this MLB code. Oops. We're going to take row one. We're going to say column names of MLB code. Those are going to be equal to columns. Oops. This should fix a lot of our issues. And then we're going to say MLB key is going to be equal to MLB. And we'll look at this one in a second here, MLB code. We're going to subtract that first row because it's just going to be a repeat of what we already have in here as the column names. So we can get rid of that. And then we're going to take all the columns except for the first one. So 2 through 5, not 50. Okay, now we're going to have an MLB key. And here we go. We have an MLB key variable that will allow us to key into our function. So now we're going to go ahead and look. I want to go back to the data frame or the data set, not the data set, sorry, the data page online here. And I want to just look at that really quick for one more second. Our goal is to pull off these data tables right here. We want to pull off the standard batting for hitting and pitching, standard batting and standard pitching for regular season and postseason for each team in any year we choose. So let's go ahead and let's go back to our screencast column here. And here we have our function. And it is called team info, and we have a team code input, we have a year, we have a stat, which is going to be hitting or pitching, and then we have a season, which is going to be any year that the team's available for. So here we have our URL, and we kind of already walked through this URL a little bit earlier. But basically, we have our common part of the URL for every single team. We have our team code, our year, and then our s.html, and then we're going to paste all this together, and then we're going to read that in as team.1. We're going to read that in using read HTML and HTML table, which is going to pull all the tables off from that page that we're reading. And then in our function, we enter these if statements. So we have if the length of team that equals 4. Then we go down to this else if here, else if team that equals 2. And then we have else. Why are those there? Those are there because if our team makes the playoffs, we're going to have 4 tables that are pulled off. If our team does not make the playoffs, we're going to have 2 tables. And if we don't type in a team code right, the team's not valid for that year, we are going to not end up with any tables, and we're going to return you did not put input in the right format. All inputs to this function must be string variables in case you put in a numeric variable or something of that nature for the year. So that is going to be what our function basically looks like. Now, to kind of go through it a little bit in more detail, if, like, let's say we type in 2016 Chicago Cubs, which is going to be the example we're looking at today. Let's say we type in that the Cubs did make the playoffs that year. So, excuse me, they are going to have 4 tables. Here we see if we typed in the stat is equal to hitting and the season is equal to regular, we're going to choose data frame 1. If we choose the stat is equal to hitting and the season is playoff, then we're going to take data table 2. If we take the stat is equal to pitching and the season is equal to regular, then the data, we're going to take table 3. And then same thing for pitching and playoff, we're going to take table 4. Now, let's go down here. If the length is equal to 2, so this means you typed in a team in a year where the team did not make the playoffs, but the year is still valid. Now, if you type in the playoffs in your season category, it's going to return your team did not make the playoffs this year. If you type in hitting, you're going to get table 1. If you type in pitching, you're going to get table 2. This is because we do not have playoff tables for this team. And then anything else you're going to get, you did not put your inputs in the right format. Let us go ahead and run this function and mess around and see what we get. Okay, we ran the function. Now this data is going to give us all we need to get. Let's see. We have the Chicago Cubs code. We have 2016. We have hitting and we have regular season. Let's go ahead and type in this data column here. Okay. We have officially used this function to scrape information off the web and format it into a data frame that we need. Perfect. So now we have all the hitting stats for the Cubs regular season. Let's type in 2017. See if we still hold here. Perfect. Now we have the Cubs stats for 2017. Let's type in a different team. Let's go to our MLB key. This is how we can do that. Let's just scroll down. Let's say, okay, Detroit Tigers, DET. Let's type in DET 2017. Well, let's type in pitching. Great. And now we have the pitching stats for the Detroit Tigers, the 2017 season in the regular season. All right, let's type in I do not think the Detroit Tigers made the playoffs this year, so let's see if our function is working correctly. So if this is working correctly and the Tigers did not make the playoffs, we're going to go down here, we're going to type in data, and it returns your team did not make the playoffs this year. So the Tigers did not make the playoffs this year. All right. So now we're going to go ahead and do an analysis on the best hitter for the Cubs in 2016, hitting during the regular season. Okay. Now, what is this going to be? So we're looking at this data frame. We have to do a little bit of cleaning here because row 9 is another column name row. I believe row 22 is another column name row. And then we have some total columns at the end that we don't need. So we're going to clean up this data here, and then we're going to get a list of our column. We're going to get a data frame of our column names really quick. Now what we're going to do with our, let me look at data clean just so we can see it. Now that we see our, now that we see our data clean table, what we're now going to do is we are now going to pivot this data longer because we want to be able to filter this and rank these players based on how they did in this season compared to everybody else on the team. So we're going to pivot longer and put all the names to metric and all the values to score. Okay, let's see. We have our best hitter column. We have Miguel Montero 32, and we have each metric WAR, games played, at bats, runs, hits, and we have his score for all of those. Okay, now we're going to select columns 2 through 4 and 17, 18. 2 through 4 is going to be player, age, and position. And then we have metric and score is going to be the other columns we select. We're going to group them by metric, and we're going to rank them. We're going to rank them, basically, we're going to rank them the higher you are, the higher you score. So if you are the number one player, you have the most home runs on the team, you're going to be ranked number one. If you have the highest batting average on the team, you're going to be ranked number one. And if you have the lowest, you're going to be ranked number however many members had an at bat. Now, the only one that's going to be different is strikeouts. If you have the highest number of strikeouts on the team, you're going to be ranked last. And if you have the lowest, you're going to be ranked first. So let's go ahead and run this up. Now let's see what we got here. Okay, look at this. We have a rank for each of these metrics here. Now what we're going to do is we are going to get an average rank. So we're going to group by player. We're going to get a rank total and a mean rank. And we're going to say which players had the lowest rank. You want the lowest rank because if you have the highest rank, that means you're like 12th on the team. You want to be first on the team. So that's why you want the lowest rank. So we're going to look at these average rank players here. And let's see what we're going to get. We get Chris Bryant has a rank total of 57 and a mean rank of 3.35. We get Anthony Rizzo has a rank total of 63 and a mean rank of 3.7. Okay, let's go ahead and throw that in a little GG plot. We're going to compare the first and second player, and we're going to go ahead and do this really quick here. Let's see. Great. Okay. Comparing ranks of the two best hitters. So now we have Anthony Rizzo, and we have Chris Bryant. Okay. So look at here. We have Chris Bryant is in blue, Anthony Rizzo is in red. So we have Chris Bryant who has the most at bats of the team. Anthony Rizzo has two. I believe this is rank one and two. They both have very similar ranked batting averages. We have Chris Bryant has less or more walks. It was ranked higher in walks than Anthony Rizzo was. They were ranked very similar. Chris Bryant had more hits. Chris Bryant had more home runs. Chris Bryant had a higher OPS. Um, Chris Bryant had more runs. Anthony Rizzo did have more RBIs. Chris Bryant had more stolen bases, had a higher slugging percentage, higher strikeouts. Chris Bryant had the highest ranking on most of the things, as shown in his mean rank of 3.35 and his rank total of 57. When Anthony Rizzo was right behind, it really wasn't very close when you step back after these two. But Anthony Rizzo's right behind at 63 and a mean rank of 3.3 or 3.71. And so what we've done is we have now pulled these data tables off of the internet. We've sorted them and we put them in a format that we can edit and manipulate. And now we have created a way that we can find the best hitter on a team after pulling the team information for a certain year for either regular season or playoffs and for hitting or pitching. Next, we're going to look at graphical information regarding can we locate a team and a stadium and put them together on a leaflet map. Okay, so the final step in the screencast that we're going to do for this project is we are going to look at graphing MLB baseball teams and their locations on a leaflet map. So you guys can see my screen and you can see that we just have a bunch of code here. And then we're actually going to turn this code into a Shiny app. And that's the stuff I'm going to be typing. But just to save some time, we're going to go through this code and see how the leaflet map is kind of created. So right off the bat, we see we have this STA dat. And what exactly is that? This is basically going to be, let's go and run this and we can see what this is going to be here. This is going to be a data set that has each the name of the stadium, the name of the team, the capacity, the latitude and longitude, and we need the latitude and longitude for leaflet maps so we can get the exact location, and then the American and National League. And one thing we have to be careful of with things like this, I had a hard time finding a data set with the locations of the stadiums, so this one's a little bit older. And let me see where this value's at. This has the Cleveland Indians on it, and the Cleveland Indians are no longer the name of the team. The MLB team for Cleveland is the Cleveland Guardians now. So in here in the STA dat function or data set, we're going to change that name with this mutate function. We're going to change that name to Cleveland Guardians. Okay. All right. So that's all done now. This next thing is a written function. It's team stadium function. So basically what it's going to do is it loads the leaflet library, the tidyverse library, the MLB plotter library. Team info is going to be a dataset created from that MLB teams dataset that we found earlier. We're going to take the team name, and then we're going to find the team color and the team logo. Because what we're going to try to do is we're going to try to create where you type in the stadium name into this function, you get out a leaflet map, which has a colored dot with the team's main color. And then you click on it, you get a logo, the name of the stadium, and the capacity of the stadium. That's going to be the goal of this leaflet map. So right here, that's kind of the initializing parts of that. Next, we go down to this color line, and we have color is equal to the team info and the team color, which is exactly what we want, and the logo is equal to the team logo from ESPN. Now we're going to be filtering this STA dat function. So we have STA dat, we're using the pipe function from the tidyverse. We then filter the team based on the chosen team that we put into our function because our input function is team up here. We're going to make a leaflet map. We're going to add tiles. Okay. We're going to add circle markers. This is where we're going to be able to do a lot of our customization. We want the latitude to be the latitude from the STA dat function. We want the longitude to be the longitude from the STA dat function. The color is going to equal to team color based on the team that we have chosen. The fill color is also going to be the color. The fill opacity opacity. I have that at 0.8 just so you can see the color a little bit better. And then the pop-up. Okay. The pop-up is we're going to paste in this image. And what I had to do is I had to paste in this URL for these images and kind of parse this URL together. I'm using this paste zero function. So what I have is the image initial URL, the logo, which this logo is actually going to be from the internet, and we're going to scrape it off. And then we have the stadium name, and that's the rest of that. To get this in the pasting function, we have to put all this in here. And then we have the capacity, which is the capacity. And all of this is from either the sta function or the MLB plotter function. And then we have our function. So let's go ahead and run this and let's see team stadium. Wow. Let's go ahead and see what this does here. I have Cleveland Guardians typed in because, okay. So let's see if you guys can see my screen here, all that you're seeing. Good. Okay. So this is Cleveland Stadium. We can zoom in. They play a progressive field. Let's click on it. There we go. We have the Cleveland Guardians logo. We have stadium is progressive field, and we have the capacity equals 43,441. Let's go ahead and see if I can do let me just think of a team. The Miami Marlins. Okay, let's see where they play. They play at Lone Depot Park. Okay, it looks like the name has changed of this park. So if you really wanted to go back in, we could go in and change the name of the stadium name in the sta function to represent what the new stadium name is for the Miami Marlins. The good part is because we use the MLB plots, data the MLB data we have is from R, and it is constantly updating. These logos are up to date. Now, to update the actual stadium data, the capacity, and the stadium name, we'd have to go in and manually do that with this data set. If we were able to find a more current data set, that would be up to date already. Let's try one more before we try to put this into a Shiny app. Let's, of course, try the Chicago Cubs, of course. Have to try it. Okay, we see the Cubby blue here. Click on it, boom. Here we go. This stadium name hasn't changed. I know that for a fact. So so yeah, there we go. All right, and let's go ahead and try to build this into a Shiny app. So first we need to make our UI, which is going to be fluid page. We have HL. This is going to be, or is it H1? Hmm. Yeah, I think it's H1. And what we're going to do here is we are going to put MLB team stadium. That's going to be kind of our title of this, of our Shiny app. And then we're going to select input. This is going to be, we want to select the team. So I want to create a drop-down menu for our team so that basically we can have the app open. There's a drop-down menu. You can then select your team and it's going to pop up. That's the goal of this this Shiny app. Okay. So what is this doing? This is saying we want to select a team and we're going to take it from the sta.team data that we have. Okay. And then we want a leaflet output and we want it to be a map. And this, we have a height is equal to 600. That's just customization and that can be changed. Okay. We have our UI. Now we need to make our server. In our server, it's going to be function, input, output. Beautiful. Okay. Now we need to make our output. Output is going to equal our map, which is going to be render leaflet. Okay. And then what we're going to do now is we're going to acquire the input to be team. And then we were going to have team stadium. Team Stadium is the function we have made earlier, and this is what is going to put our team into a leaflet map because we've already built this function earlier. So basically, we're putting this function that we built earlier into a Shiny app so that it's a little bit more fun and a little bit easier to use. Okay, and now we've kind of completed this setup here. All we have to do is click Shiny app, UI, server. Okay, and let's see if this worked. If not, we may have to go change some things here. Oh, hold on. Let me see if you're seeing my screen. You're not. I'm gonna share the screen of the app that just popped up. Okay, here we go. You guys are now seeing it. Okay, so right here we have the Los Angeles Angels up. So their main color is actually apparently blue on this MLB R data frame. So that's interesting. But we click on it and we're at Angel Stadium. We go here, we can select a team, the Oakland Athletics. This one's a little bit behind. This stadium location needs to be updated in the STA function, but we have the A's logo, we have the stadium, and we have the capacity. The Detroit Tigers. There's a logo, stadium, capacity. This is pretty cool. I found myself just clicking around on here, just messing around, just seeing some of this stuff. Cincinnati Reds, Great American Ballpark, great location on the river. Of course, we'll check the Royal Stadium here at Kauffman Stadium. The color blue, main color blue. We got the KC logo, Kauffman Stadium. And then let's see. New York Yankees down in the Bronx. There we go. And that's the leaflet function and how to put it into a Shiny app for MLB ballpark locations. And yeah, so that's my 351 screencast project. Thank you guys for listening and have a blessed day.